Hey guys, this is the lesson over 11.2. So there is a PDF copy of these notes already. So if you're able to make sense of them, then that's awesome. But I'm going to go through them with you. I'm going to share them on my screen and talk through the examples with you and hopefully make that a little bit easier to understand. Give me just a second here. Share my screen. And you should be seeing this. So we are going to be looking at section 11.2. We're going to be finding what's called excluded values, and we're also going to identify what's called asymptotes. So excluded values are when we're looking at a function, and that function is anything in that function that makes it undefined. So think of this like in terms of a fraction, whatever makes the denominator equal 0, that's an excluded value. So that means that X can be anything that we can think of, but it cannot be this one value because it makes the denominator equal 0. The second thing that we're going to talk about is an asymptote. So this is a line on the coordinate plane that the graph approaches, but it never actually touches it or crosses it. So whenever you're graphing these, which we're not going to do, I'll show you an example of what it looks like, but this is a line that's basically like an imaginary line, and our graph is going to get closer and closer and closer, but it's never actually going to touch this line. It's just going to get really close to it. So first thing that we're going to talk about is finding the excluded values. Okay, so this first one here, we've got y equals -2 over x. Anytime we're finding an excluded value, we are only looking at the denominator, which in this case is just x. Okay, on b here, we've got in the denominator x plus 1. On this function c, we've got the denominator of 4x minus 8. So anytime we're looking for excluded values, we're only looking at those things in the denominator. Okay. So on the first one, if I set the denominator equal to 0, it's just going to be x equals 0. So this one's really easy because you don't have to solve anything. It's just x is equal to 0. X can be anything else except for 0 because that makes this fraction undefined. It would say -2 over 0, which we know that we can't do that. Okay. For b, on the other hand, I had x plus 1 in the denominator. I have to figure out what makes that 0. So the easiest way to do that is just write an equation that says x plus 1 is equal to 0. If I solve that by moving the plus 1 to the other side and subtracting it, I'd be left with x equals -1. So that would be my excluded value. X can be anything else, but it cannot be -1 because if I plug -1 into my problem there, it'll be -1 plus 1, which is then 0, which makes my function undefined. Okay. And for the last one here, denominator is 4x minus 8. Easiest way to figure out what x is setting it equal to 0. So if I solve this, I'm going to add 8 to this side. So you're going to have 4x equals 8. And then if I divide by 4 to get x by itself, 8 divided by 4 is going to give me 2. So again, x can be anything that I can think of except for 2. And they're asking me what's the excluded value, so it would be x equals 2. If I sub that in up here, I should get 0, which makes it undefined. So that's excluded values. You're only looking at the denominators. So the next thing that we're going to talk about is the asymptotes. The first part of what we just did, the excluded values, that represents a vertical line. So notice how on all of these it was x equals. X equals is a vertical line that runs up and down. If I graphed this line, x equals 0, it would be a vertical line going through 0. X equals -1 is a vertical line through -1, and so on. Okay. So there's two types of asymptotes. The one that we just were talking about is a vertical asymptote, and that's your excluded value. So again, looking at your denominator, that's going to tell you what that is. You also could have a horizontal asymptote. So if you have an extra number out here that's being added or subtracted, that is going to be your horizontal asymptote. This does not always happen. There is not always a horizontal asymptote, just sometimes if there's a number out here. Okay, so again, remember that these are lines on the graph. These are lines that our graph is not going to touch. So we already found vertical ones. Okay, horizontal ones would be running this way. So they're all going to be y equals whenever we're finding those. So we're not graphing these because it's a lot of stuff to try to tell you to do over computer online. But this is an example of what a graph would look like if you had asymptotes. So pretend like we graphed this, and these red lines right here would be like your functions. Okay, so these little loopy lines right here, those are your functions. And the blue lines are your asymptotes. So this blue line right here, x equals 3, that's a line that it's getting really, 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 really close to, okay, up here, and again, really, really close to down here, but it's never going to touch that line, and it's never going to cross it. Horizontal asymptote in this case is this one right here. Looks like that's running through 1, so that would be y equals 1. And again, notice how this graph is curving and going closer and closer and closer, but it's never actually touching it. And same thing on this one, it's getting closer and closer, but never touching it. So that's what these lines look like. So what we're doing is we're finding what these blue lines would be. We're not putting anything on a graph, you're just telling me what they would be. So we're going to find the asymptotes for each function. Okay, for A, we've got y equals 2 over x plus 2 plus 1. And for B, we've got y equals 1 over x plus 1. So starting with the first one, we're first going to notice that this has a denominator down here, and I can find the excluded value, which is what we were already doing. That's going to tell me my vertical asymptote. This one also has a horizontal because of this extra out here. Okay. So my vertical asymptote comes from the bottom right here, that x plus 2. If I set that equal to 0 and solve it, it's going to be x equals negative 2. My horizontal comes from whatever this number is right here. Okay, if it's a positive 1, it's positive 1 here. That's the easy part. You don't have to solve anything. So it would just be y equals 1. Okay, remember that vertical is always x and horizontal is always y. Okay, now on letter B in your denominator, you've got x plus 1. If I set that equal to 0, I'd have x plus 1 equals 0. If I solved that, I would get x equals negative 1. That would be my vertical asymptote. There is no horizontal asymptote here. Okay, you would just put none for that if it asked you. But that's because there's no number out here. What would be right here, there's nothing, so there is no horizontal. Okay. So that's just a quick overview of the notes. If you need to go back and watch it again, do that. But on your homework, you're going to do on page 687, 13 through 19 odds, 23 through 33 odds. It's only 10 questions. On the directions for 23 through 33, it says to identify the asymptotes and then graph it. You're not graphing the function, you're only finding the asymptotes. Right? And then there's a form for you guys to submit on Google Forms on the assignment. Okay, so if you have any questions, let me know. Hopefully this helps explain some stuff. I know it's not ideal that I'm not working it out, but hopefully this was something that you can catch on to pretty quickly. So if you have a question, let me know, and good luck. Have a good day.